If you want to build a skyscraper today, you need a small army, thousands of pages of structural calculations, GPS synchronized excavation equipment, and cranes that can lift hundreds of tons. We consider ourselves the masters of construction. We look back at history as a slow climb from primitive tools to our current digital supremacy. But 4,500 years ago, on a plateau in Egypt, someone executed a project that still mocks our modern engineering standards, the Great Pyramid of Giza. It is composed of 2.3 million stone blocks. It weighs 6 million tons. It was built with a precision that defies the tools of its time, and perhaps even our own. As a structural engineer, I don't see a tomb when I look at this. I see an impossible blueprint. I see a nightmare of logistics and tolerances. Today, we are going to look past the myths and analyze the Great Pyramid through the eyes of an engineer. What was the real cost of this project, and how did they achieve the impossible? In engineering, everything starts with the foundation. If your base is off by a few centimeters, your structure will lean or fail before it even reaches half its height. The base of the Great Pyramid covers 13 acres. That's about 7 football fields. Across this entire massive area, the foundation is level to within 15 millimeters. Let that sink in. To achieve that kind of level today, we use laser rotators and satellite-linked surveying equipment, but it's not just the level. The pyramid is aligned to true north within 3/60ths of a degree. This isn't magnetic north, which shifts over time. It is the rotational axis of the Earth itself. As a modern engineer, I have to ask, how did they establish such a precise baseline? This suggests a level of geodetic knowledge that we thought wouldn't be discovered for another 3 millennia. They weren't just building, they were mapping the planet onto the stone. Now, let's look closer at the materials. While most of the pyramid is limestone, the king's chamber is built with massive granite beams. Granite is one of the hardest stones on Earth, loaded with quartz crystals. To cut these blocks today, we use diamond-tipped saws or high-pressure water jets. Yet when we examine the tool marks left on these ancient stones, we see evidence of a feed rate, the speed at which the saw cuts, that is significantly faster than our modern industrial tools. If you look at the joints between these 80-ton blocks, the precision is terrifying. You cannot fit a razor blade or even a human hair between them. This isn't just manual labor. This is high-precision manufacturing. It suggests that they were cutting and fitting these stones like they were pieces of a watch, but on a megalithic scale. Let's talk about the heavy lifting. Most of the blocks weigh around 2.5 tons, but those granite beams in the king's chamber, they weigh up to 80 tons each. That is the weight of a Boeing 737. These stones were transported from Aswan over 800 kilometers away. The official theory suggests wooden ramps and thousands of slaves, but as an engineer, look at the math. A ramp reaching the top of the pyramid would need to be over a mile long and would contain more material than the pyramid itself. Consider the logistics. If you laid one stone every 2 minutes, working 24 hours a day, it would still take 20 years to finish. Think about the infrastructure needed just to feed, house, and manage 20,000 workers in the middle of a desert 4,000 years ago. No trucks, no refrigeration, no modern supply chains. The management of this project alone is a bigger marvel than the architecture. Beyond the stones, there is the math. If you take the perimeter of the pyramid and divide it by twice its height, you get pi. If you take the height and multiply it by 10 to the power of 9, you get the approximate distance between the Earth and the Sun. Are these coincidences? Engineers don't believe in accidents. We believe in design. When we see the golden ratio integrated into a structure, we know someone put it there on purpose. The pyramid isn't just a building, it's a physical archive of universal constants. It's a message written in the language of geometry. If we tried to build the Great Pyramid today with our most advanced cranes and 3D modeling software, it would cost over $5 billion. And even then, achieving that level of solar and cardinal alignment would be an immense challenge for any modern contractor. So we are left with a choice. Either we accept that an ancient civilization possessed a technology we don't understand, or we admit that our history books are missing a very important chapter. The Great Pyramid remains the world's most enduring engineering mystery. It is a testament to a lost mastery of the natural world. In our next video, we will explore the acoustic theory. Could this structure have been a massive power plant? I am the Arcana Architect. Join the journey, subscribe, and let's keep decoding the unknown. I'll see you on Monday.